Welcome back to our remote lecture series. Today we're going to take on a project, and that project is going to be repairing and rewiring a lamp or a light fixture like I have here. So as part of that process, we're going to learn how to clean this up. We're going to learn a little bit about replacing the existing wiring, replacing plugs, and also the option of adding a switch to be able to turn that light on and off. We're going to come to understand some of the definitions that are used for describing wire gauge and how a wire gauge determines what kind of voltage or amperage that it is designed for. We're going to look at solid wires and stranded wires. We're going to talk about the two most common forms of electricity that we use for powering devices. That's going to include alternating current and direct current. We're going to look at what we refer to as circuit interrupters, and circuit interrupters include things like circuit breakers and fuses. We're going to, as I already mentioned, we're going to look at some different switching devices that allow us to turn things on and off. And we're also going to look at some things like what are called terminals and splicers that allow us to join wires together in a way that's consistent with electrical codes or standards for wiring. We're going to look at some of the tools that are used for measuring electricity, including things like voltmeters and voltage detectors. We're going to look at wire strippers that allow us to strip off the insulated sheathing around wire for making these terminal and splice connections between pieces. And we're also going to look at what are called crimpers and cutters that are other things that you find on things like electrician's pliers like these. We're going to look at wire nuts, which are these guys right here. And we're going to talk about how those can be used for making electrical connections, how soldering can be used for electrical connections, and how electrical tape can be used to insulate those connections to make them as safe as possible. Now, we're also going to, because we are primarily focusing on applications of alternating current, we're going to talk about alternating current paths, which include things like what we generically refer to as an active wire, which is typically a black wire, but may also be a wire that's either that's any color other than green or white. We're going to talk about neutral wire, which is which carries the current back from the active wire, and that's always going to be white. And we're also going to talk about the function of a ground wire, which is an additional path that carries electric current back to the earth instead of through us, should there be what's called a short circuit, which can result in a fire or potential electrocution, or it could, if it's a data-based device like a computer, how that can adversely affect a computer. Ground wires also help stabilize current in a way that minimizes spikes or surges in that energy transfer. We're going to familiarize ourselves with a couple of definitions that include amperage, which is the practical measurement of electrical flow or electrical current. And we're going to also look at the directed motion of free electrons in a conductor or a wire and how that constitutes an electrical current. We're going to also look at how voltage is used as a means of measuring the pressure that occurs as the current flows back through that neutral wire. So as flow increases, the repulsive forces or pressure between the electrons that are streaming through that wire increases. So electrical pressure is called a difference in potential or voltage or electrical force, and the unit of that measure is a volt. And volts are commonly used within a wide range of electrical practices to measure that energy output. So with that being said, I'm really excited to have the opportunity to focus on something that I frequently get questions about in the workplace, and I hope that you find this to be useful and interesting for your own practice. Okay, one of the first things that we're going to want to do is to remove the old socket, and we're also going to strip out the old wire, and then we'll go about cleaning this fella up. So sometimes these guys unscrew, but it's often the case that there is a screw in place that needs to be removed in order inside of the socket itself. So I know this sounds ridiculous, but I'm going to say it anyway. Before you ever start to work on anything that uses electricity as a source of energy, we need to absolutely ensure that that's disconnected from its power source. It's also important to understand that some things like televisions can have an electrical component in them that stores energy, and if you were to inadvertently come in contact with that capacitor, which is storing energy in it, even though that device is disconnected, it could still discharge enough electricity to seriously injure you or kill you. So there's a cautionary note for you when it comes to taking apart certain electronics or electric motors that have capacitors built into them. So let's get a proper screwdriver and see if we can't get this guy loosened up. And when I say proper screwdriver, I mean a screwdriver that is appropriately sized for what we're doing. And in the case of working with electricity, there are special screwdrivers that you can get that have a voltage rating, and that tells me that it's insulated to reduce the possibility of me getting electrocuted should I come in contact with a live wire. So let's go inside and see if we can just part this guy out. Looks like I may well need to get a smaller screwdriver for this. Okay. There we go. So that's our top section of the ceramic bulb holder. And now I'm going to go ahead and loosen up these two contact screws that my lead wire and my neutral are connected to. And I should be able to pull the wire through just like so. And I'm not sure how this is fixed into this shade. Let's see if we get some action by loosening up these two. Looks like I will need a smaller screwdriver yet. Okay, I had to bust out a little set of these micro screwdrivers. It's often the case that fasteners that have sat for decades like this has might well frozen in place due to oxidation, and we can use what are called penetrating fluids. WD-40 would work to get those to break loose. So those two screws allowed this to come off of the base, and you can see that that guy is busted in half, so that needed to be removed. And this base looks like it could be soldered in place. So that might prove to be a little bit of a challenge for us. Just for the hell of it, I'm gonna just see if I can get that to budge a little bit. So I'm gonna try to gently coax it. So I'm gently working my way around that. If it's a compression fit, I should be able to get that to pop out. And I'm getting a little bit of movement, which is encouraging, but that is hanging tight. So maybe now's the time for me to perhaps go and see if I can't clean this up a little bit, and that might give me a better view of what's going on inside of here. It is entirely possible that this little ferrule here is threaded. So before I go any further, I might try to get some pliers on this, but I want to use pliers that have smooth jaws, or that I can put leather in between those pliers and the jaws so it doesn't mar the surface of this. Okay, so I have a little pair of what are called slip joint pliers, and I cut a piece of leather to go in between it so that the teeth, which are what help give these a grip on the surface of the material, are not going to shred or tear up that brass. So I put that copper in that piece of leather in between this copper and the jaws of my pliers. And I like the way that's working. Let's see if we can get a look at what's going on the inside as we rotate that. So I can see that the whole thing is turning on the inside, which to me suggests that those might well be screwed together. Holding on to that little escutcheon on the inside. That doesn't, that I can get that to rotate, but I'm not getting it to unlock. And again, my guess is that there's just so much corrosion in there that those two pieces have fused together. So I'm going to go ahead and clean this up, and then we'll come back and we'll give it another go. The way that I'm going to clean this up is by using an abrasive pad, and these nylon pads are really good for cleaning up the surface of materials, but I want to make sure and use one that is ultra fine, like the Zero. So here we have coarse, medium, and fine. So I'm going to take that ultra fine, I'm going to take it to a sink, I'm going to scrub it up, and we'll see where we're at.